This video is intended to cover some basic programming concepts, but it isn't intended to teach a specific programming language. We start with the idea that, whatever it looks like, the computer is basically a box of components that needs electricity to run. Through a combination of components, all processing is done based on whether there is an electrical pulse or not. We can represent the presence of electricity with a 1 and the absence of electricity with a 0. At school we learn mathematics using base 10, otherwise known as binary. The digits we use in base 10 run from 0 to 9. When we look at what a number means in base 10, we think of the rightmost number being units and the next digit is the number of tens. The next number of that is the number of hundreds. So if we have the number 134, it means we have 103 tens and 4 units. So when we add numbers together, we start by adding the units. If the total is 9 or less, we write the number down in the rightmost column. However, if the number is greater than 9, we write down the units in the first column and carry the tens into the second column. So if we add 8 and 2 together, we write down 0 in the units column and 1 in the tens column. When it comes to computers, as I previously said, we represent the presence of electricity with a 1 and its absence with 0. This puts us in base 2, otherwise known as binary. So as we see, in binary we use the digits from 0 to 9, but in binary we only use the digits 1 and 0. In binary the rightmost column is units, which can contain 1 or 0. If you want to represent larger numbers, then you need to use the second column, which represents the number of twos. So the number 2 would be represented as 10, the number 3 would be represented as 11. To represent the number 4 we would move into another column, and so 4 would be represented as 100. When we add two numbers together, such as 1 plus 1, we record the units as 0 and carry the 1 over into the next column. To see how additions are carried out in an electrical system, we can look at this simulator. The shapes in the middle, known as logic gates, would be implemented using electronic components. In this demonstration you can see that when A is 1 and B is 0, the sum light is illuminated, showing that 1 plus 0 is 1. This also applies when A is 0 and B is 1, then the sum is also 1. However, when we set both A and B to 1, and know that adding it together will give us 2, we see that the sum bulb goes out. In other words, it is set to 0, and the carry out bulb is illuminated. So in this case the sum bulb is the units column and the carry out is the twos columns. Do you know what would happen if all three switches on the left were pressed? Over the years, there have been many different programming languages. Some are rarely used these days. As we develop new ideas about the way that we want to use computers, we have needed to develop different programming languages. Variables can be used to store all sorts of data. Some common data types include text or strings of characters, integers which are whole numbers, real or decimal numbers. Boolean data types hold a value of true or false. It's possible to put data into a variable using the direct assignment statement, as you can see in the first example. Alternatively, you can prompt the user to enter a value, or a value can be read from a data file or database. In this example, the word in brackets is the name of the variable that the data is to be saved in. At this point it's worth mentioning the name of variables that you use. Where possible, you should use meaningful variable names so that anyone reading it can guess what it's used for. However, there are certain words you can't use. These are known as reserved words, and they vary with each programming language. They tend to be words that are used as command words, such as read or print. As you can imagine, the computer needs to know how to react when it comes across a specific word. Using a command word as a variable name could cause confusion for the programmer too. It's possible to change the value held in the variable throughout the program. For example, in a game you might want to increase the score when an enemy is defeated or some goal is achieved. The example we have here might look confusing, but basically it just tells the computer to take the current value that is held in the variable score, add 10 to it, and then put the new value into score, overriding the old value. The important thing to remember about variables is that you can carry out calculations, assuming their data types allow it. So if you multiply two variables together, you're really multiplying together the values held in those variables. In this example, we're testing the data held in the variable area. If it's less than or equal to 20, then the area is too small, but if it's greater or equal to 50, then it's too big. Anything in between, i.e. from 21 to 49, is just right. A case statement is another way of making the decision based on the value of a variable, but it can test for many more options than a simple if statement, and it does away with the need for multiple if and else if statements. Some iteration statements allow a loop to be performed a specific number of times, whereas others loop until a certain condition is met. In this example, the user will be prompted, repeatedly, to enter a code until they enter HG3, at which point it will come out of the loop and continue with the rest of the program. Procedures are used to keep programs tidy, and therefore easy to maintain. Procedures are a piece of code that you know will be used several times within a program. In the example on the left, the procedure is called draw square and is laid out at the top. Whenever we want to run a procedure, we just put its name in the program so that the computer knows to go off and run the procedure, before coming back to the main program and carrying on with the next command. Some programming languages use an object-oriented approach. It can be quite a difficult concept to grasp, but it can also be very powerful. In object-oriented programming, the object itself should contain all of the data and code that it needs to function. For example, in a graphical system you might have an object that is a button. The button will contain instructions about how it should look, color, size, font style, etc., and how it should behave when it is clicked. Event-driven programming can use procedural or object-oriented programming. In a visual system that has objects such as buttons and icons, each object must be told how to react to different events. In this example, left-clicking on the blue button will trigger a piece of code that will open the user's email program. Meanwhile, you would normally expect single left-click on the yellow icon to select it, but double left-click would run code to open the word processing program. In Windows, right-clicking the icon opens a menu. ActionScript is a programming language used in flash animations and videos. Here we see a function which is similar to a procedure that is called goNext. When this function runs, it will move to the next frame of the animation or video. There's a similar function called goBack which, when run, will move to the previous frame. The highlighted line here shows the command that tells the next button how to react to being clicked. When a click is detected, the function goNext is called. A similar piece of code applies when the back button is clicked.